Alright, perfect German weather conditions to start an RCPlane project. Hi, I still got this RC drone set from China and the remote I wanted to test for a long time. Also the spare styrofoam I have could be a good material to build a plane. The parts I have here are the RadioLink AT9 controller and the matching R9DS receiver, some brushless motors, some ESCs, some servos and some props for quadrocopters, but those could also work for a plane. Actually, I have no clue what I'm doing. It's my first try on RC planes, so don't take it as a tutorial, but I wanted to share it anyways. I don't have the battery yet, but I will build one later. I will keep an updated list of the parts on my project page, as well as some useful links to RC stuff. After pairing the controller with the receiver, I tested the servos first. Then I connected the ESC to the motor, the receiver and my bench power supply. I didn't know what a voltage to use yet and how to supply the voltage to the receiver. It turns out around 12 volts for this ESC and motor is okay. The ESC provides also the 5 volts for the receiver and the servos. 3 lithium cells in series are optimal in this case, so I took my self-made drill power pack for further testing.
Watch me losing some fingers. Oh! Oh, full power. Oh, something's flying away here. Oh!
The motors and ESCs came without any connectors and I didn't have any fitting around, except for these 3.5mm bullet connectors. I had to set my soldering station to around 380 degrees C to get it soldered. The connectors are still a bit oversized. Wrapping them in heat shrink prevents them from shorting. This worked pretty good. Since I missed to order a proper 3S LiPo power pack in time, I had to improvise one from those refurbished tablet batteries. I removed the protection circuit since it had some kind of low current limitation and connected the 3 cells in series to a single stack. I also added a balancing connector. The significance of balancing increased to me since my housemate almost burned down the house while his huge pack decided to explode while he was sleeping. I also didn't have a proper battery connector, so I also took these 3.5mm connectors. But you should use XT60 connectors for this. The pack seems okay, but it's not protected and I'm so scared of it that it has to sleep on the balcony. Until now it works excellent and provides enough current. That could be problematic with 18650 cells. I laid out the electronics and started to draw a random plane model. Cutting styrofoam always makes a huge mess. Using some kind of hot wire to cut it properly could be a solution. So I built a simple cutting tool which simply consists of a steel wire which can be tensioned. The steel wire is connected to the aluminium pipes at the end. The holder and the tensioning rope isn't conductive, only the steel wire. So when we connect a power source to the backsides of the aluminium pipes, the current flows through the wire and heats it up. Steel wire is much more resistive than aluminium and copper, so the wire will heat up first. I tried different currents and ended up using 4 amps for my cutting bow. This didn't produce much fumes, but it was still hot enough to cut through like a hot knife through butter. I still opened the lab and used a fan and even protective glasses at a later stage, since the fumes didn't feel healthy in my eyes and brain the following night. At my first attempt I realized this cutting technique wasn't very precise free-handed. But it should work anyways. I improved that later by using aluminium profiles as a rail for the wire to glide on. Since I'm a nerdy guy, I also tried to cut some kind of airfoil so the wing would glide nicely through the clouds. To not overcomplicate the plane, I was building a wing-blended body where the elevators and the ailerons are combined. So we need only two of those what's called elevons and a rudder, which came out a little bit undersized in my case. To be able to use elevons, you need to activate a specific mixing on your remote. On the Radiolink 89, the model type has to be set to glider 1A plus 1F. The flaperons need to be deactivated and the elevons need to be activated. I mounted the motor to a plate and used some stiff coat hanger wire to fix it to the styrofoam, which was less stable than expected.
Oh shit! Oh shit!
I also used some thin rods to mount the control surfaces.
Okay.
Then I checked the orientation of the servos to be in the right place and used also the rods and some aluminium sheet as a lever at the control surfaces. Should have probably researched more how it's done properly, but it was really fun to explore what works and what not. But it looks okay, don't you think? After this test I fixed everything.
Okay.
Working all night, I went happy to bed, just to discover my brain fart in the next morning. I mounted the wing upside down so the airfoil I made so proudly would pound the plane directly into the ground. I was too lazy to redo all the servos again, so I used some duct tape, put everything in place and used my improved cutting technique to remove the airfoil again. After that I used some duct tape to make the thin edges a little bit more impact proof. Done! First day in long time where it wasn't raining and the wind stopped. Perfect conditions. Tony was helping me with the recording of the stunning maiden flight that day. The moment of truth.
Nein!
The plane really sucked. I fixed it with some duct tape and put on a new prop and tried again. At least it was a bit of fun.
Okay. New try. Vertical start. I give up.
I learned a lot and my New Year's resolution is to double the flight time with the next model. If you enjoyed watching my learning process a bit, you should really subscribe to see more successful upcoming projects. I might take a short break from RC stuff though.
Bye bye.
Oh nein!